All right, we're diving into a really interesting theoretical paper today. It tries to build a bridge between two worlds you'd think could never meet: modern physics and, ancient systems like astrology. It's built on a pretty radical idea. What if the huge fight between them isn't about one being right and one being wrong, but about them just speaking different languages? For centuries, science has pretty much put things like astrology in the superstition box. The thinking is, hey, there's no real evidence, right? But this paper flips the script. It asks a totally different question. What if these ancient systems weren't just making things up? What if they were describing real, physical things, but just in a language that we've forgotten how to speak? And that right there brings us to the absolute core of this paper's argument. It's a bold claim, for sure. It's suggesting that maybe the problem isn't that astrology is wrong. Maybe the problem is that science and these old traditions are using completely different conceptual languages. So it's not a question of truth, it's a question of translation. Now, let's be super clear about something. The point of this paper isn't to prove your daily horoscope is right, not at all. It's more of a conceptual thought experiment. It wants to shift the whole conversation away from, hey, is this prediction accurate, to something way more fascinating. What real, natural phenomena could these ancient models have been trying to describe all along? See, the paper makes a great point. If you actually look at the roots of classical astrology, it's not really about some gods in the sky pulling puppet strings. At its heart, it's all about relational geometry. I mean, it is obsessed with the angles, the patterns, the shapes that planets and stars make as they move. Okay, so let's get into the science of it. To even begin to build this new framework, the paper grounds its entire argument in three fundamental concepts for modern physics. This is where the real work of building that bridge begins. First up, the concept of a field. Modern physics has moved past the idea of an empty universe where objects just pull on each other. Now, the thinking is that space itself is structured by fields. Think of the gravitational field or the electromagnetic field. The key takeaway is that we're not separate from these things. We are literally swimming in them, completely embedded. Okay, number two is frequency. It's pretty simple, really. Anything that happens over and over again has a frequency. The planets going around the sun, that's a frequency. Your heartbeat, that's a frequency. But just knowing the frequency isn't enough. To really get what's going on, you have to understand how different frequencies interact with each other. And that leads us to the most crucial piece of the puzzle: phase. Phase just tells you where something is in its cycle. And this is everything. Because when two different cycles or waves meet, their phase relationship is what determines what happens next. If they're in sync, in phase, they boost each other. If they're out of sync, they can actually cancel each other out completely. So the big question is, how do these physics concepts, field, frequency, and phase, apply to planets and maybe even to us? Well, this is where the paper really steps up and takes on one of the biggest scientific arguments against astrology. Think about it. The planets in our solar system, they all move in these really predictable, repeating orbits. And because they do, they can't help but form geometric patterns and phase relationships with each other, from our point of view here on Earth. So all those things astrology calls aspects, conjunctions, oppositions, squares, you could just see them as the natural phase structures that pop up. Okay, so here's the classic objection, right? The number one argument you'll hear is that the gravity from, say, Jupiter is just way too weak to have any effect on us. And you know what? The paper totally agrees. But then it completely reframes the problem. It says, hey, you're looking at it all wrong. It's not about the strength of the force. It's about structural resonance and how things are aligned in phase. And the paper uses a perfect analogy to explain this: the tides. The moon's gravitational pull on any single drop of ocean water is practically nothing. It's tiny. But because of the overall structural and phase relationship between the moon and all of Earth's oceans combined, that incredibly weak force creates a gigantic, totally measurable effect. It moves the entire ocean. And this is where the paper makes a pretty provocative connection. It points out that, just like the surface of the Earth, the human body is also a fluid-based system. We're talking about 70 to 75% water. So the suggestion is, if this phase resonance can affect a massive fluid system like the ocean, isn't it, at least theoretically possible, it could affect a much smaller one too? All right, this next part is what I find really cool. The paper doesn't just stick with analogies. It actually tries to build a formal mathematical model out of this. It attempts to translate this whole idea of phase efficiency into the language of math. So they call it the vector projection model. Here's the basic idea. Imagine I naught is all the cosmic influence that's out there. But I is the actual amount of that influence the system can receive. And what decides how much gets through? That little cosine theta right there, which is just a function of the angle between things. So, put simply, it's not about how much power is being blasted at you, it's about your alignment to that power. Let's just walk through what that means. So, if planets are at a 0-degree angle, a conjunction, the cosine is 1. That's maximum efficiency, total reinforcement. But at a 90-degree angle, a square, the cosine is 0. No projection at all. The model sees this as creating tension. Then, at 180 degrees, an opposition, the cosine is -1. That's a reversed projection, which could mean conflict or maybe even transformation. Suddenly, good and bad aspects are just different measures of mathematical efficiency. And what this all leads to is a potential paradigm shift. It's asking us to stop thinking about planets hitting us with some kind of direct force. Instead, the model wants us to think in terms of phase efficiency. How well is a system, like a person, able to absorb and use the energy from the cosmic fields it's already in? If you look at it this way, it totally changes what these ancient systems are for. They're no longer about predicting the future, telling you you're going to win the lottery next Tuesday. Instead, they become descriptive models. They're like a weather report for the cosmic energy, describing the structural conditions and the relationship between you and the universe around you. Which brings us right to the paper's final big picture summary. It really ties the whole thing together. It goes like this. The universe is a field. Those fields have frequencies. Those frequencies create phase relationships. And what we call destiny or fate, well, that might just correspond to the projection efficiency that's determined by those very phases. Now, the paper isn't claiming it's proven any of this in the lab. It's not about that. What it's really offering is a new language, a whole new way of thinking about these things. And it leaves us with this really powerful question to chew on. If we change the language we use to describe the universe, could we fundamentally change our entire understanding of our place within it?